This is Anupama. In this video, I'm going to solve a problem from straight lines. What is the question given is that if P and Q are perpendiculars from origin to the straight lines x secant alpha plus y cosecant alpha equals to A and x cos alpha minus y sin alpha equal to A cos 2 alpha. Prove that 4p square plus q square equals to A square. So, first, let us take the equation x secant alpha plus y cosecant alpha equals to A. Okay, secant is nothing but inverse of cos, that is x by cos alpha plus y cosecant alpha is nothing but y by sin alpha, which is equals to A. Now taking after taking LCM, what you will get here, you will get the LCM sin alpha cos alpha. Here cos alpha is there, so sin alpha into x plus here sin alpha is there, so cos alpha into y, that is y cos alpha equals to A. Now bring this denominator to the other side. What we get, x sin alpha plus y cos alpha equals to A sin alpha cos alpha. If we multiply both sides with 2, what we will get, 2x sin alpha plus 2y cos alpha equals to 2a sin alpha cos alpha. Why and this why we did this multiplication by 2, both sides for balancing, but why we are doing why we are multiplying 2 in the other equation? If you observe, that is a cos 2 alpha. So if you multiply this also you with 2, what you will get, 2x sin alpha plus 2y cos alpha equal to, this is A is a side, and if you observe 2 sin alpha cos alpha, 2 sin theta cos theta is nothing but sin 2 theta. Here theta, in the place of theta we have alpha. So at last we got sin 2 alpha, A sin 2 alpha. And I bring this A sin 2 alpha to the left side. I got the equation 2x sin alpha plus 2y cos alpha minus A sin 2 alpha equals to 0. And what is the second equation given, x cos alpha minus y sin alpha equal to A cos 2 alpha. So this is equation 1, this is equation 2. And what is the particular thing given in the question, P and Q are perpendiculars drawn from these two equations. So I took here P equals to, what is the formula, actual formula from equation 1. P is from equation 1, perpendicular of equation 1. So what is the formula? Mod of constant. Means in the line equation, what is the constant we have? That we have to take. By root of a square plus b square. A square and b square are the coefficients of x and y respectively. So p is equals to, what is c here? Minus a sin 2 alpha by a square is nothing but 2 sin alpha. 2 sin alpha is the coefficient of x. So 2 sin alpha whole square is 4 sin square alpha. 2 cos alpha whole square is 4 cos square alpha, which is equals to mod of minus a sin and 2 alpha by root of, in this both we have common 4. So 4 into sin square alpha plus cos square alpha, which is equals to mod minus a sin 2 alpha by root 4 into 1. Again, why we got 1 here? Sin square theta plus cos square theta is equals to 1. So minus a sin alpha by root 4 is equals to, so next what we got, ma? Root 4 minus mod of minus a sin 2 alpha by root 4. Root 4 is nothing but 4 is nothing but 2 square, right? 2 square. Root 2 square is nothing but square and root get cancelled and we'll get 2. So mod of minus a sin 2 alpha by 2 equal to mod a minus, if you have minus in the modulus function you will get the positive. If you have minus or positive you will get the positive output. Okay, so a sin 2 alpha by 2, which is equals to P. Next perpendicular from equation 2 is Q. For this also same formula. Okay, and in that equation we have, what is the constant, minus a cos 2 alpha by cos square alpha plus sin square alpha. This is x coefficient, this is y coefficient. So again cos square theta plus sin square theta or sin square theta plus cos square theta is equals to 1. So mod of minus a cos 2 theta plus 2 alpha by root 1 is nothing but 1. So q equal to, what you will get at last, a cos 2 alpha. Now what we have to prove here, 4p square plus q square equal to a square. Now p I got here, a p equal to a sin 2 alpha by 2 and bring 2 this side, the other side. You will get 2p equal to a sine 2 alpha. Now, here what we have to substitute, what we have to do, we have to square both sides. We have to square both sides. Squaring both sides, we get 4p square equal to a square sine square 2 alpha. And for q also, you are squaring both sides. Q square equal to a square cos square 2 alpha. We have to prove 4p square plus q square, no? So I added these two. A square sin square 2 alpha plus a square sin square 2 cos 2 alpha equal to, in this both a square is common. So sin square 2 alpha plus cos square 2 alpha you will get, which is equals to a square. Why? Since sin square theta plus cos square theta is equal to 1 and here theta equal to 2 alpha. So sin square theta plus cos square theta. Here we have to take it theta is equals to 2 alpha. That's why we got here 1. So a square. So 4p square plus q square equal to a square. Hence proved. This is the thing we have to prove.